Hydrocarbons are organic compounds containing only hydrogen and carbon. They play an important role in our life as they meet more than 90% of the energy requirements of the world. Also, they are the major sources of various other organic compounds which we use in different walks of life. Coal and petroleum are complex mixtures of hydrocarbons. Coal tar, a product of destructive distillation of coal, when subjected to fractional distillation, produces various aromatic compounds including benzene. These compounds are used in the preparation of various industrially useful products such as polymers like polystyrene, dyes, drugs, etc. Petroleum, on the other hand, is a major source of alkanes and cycloalkanes. When it is subjected to fractional distillation, the various fractions obtained are used as fuels for different purposes. For example, natural gas in the form of CNG, that is, compressed natural gas, and LNG, that is liquefied natural gas, are used as automobile fuels. Liquefaction of petroleum gas renders a very useful domestic fuel in the form of LPG. Kerosene oil is also used as a domestic fuel, but it is more polluting as compared to LPG. Petrol and diesel are also used as automobile fuels. Among the automobile fuels used, CNG or LNG are the clean fuels. That is, these are non-polluting fuels. Other higher hydrocarbons are used as lubricants, solvents for paints, and so on. Hence, we can say that the hydrocarbons act as sources of energy. Now, let us look at the classification of hydrocarbons. On the basis of carbon skeleton, that is, the type of carbon-carbon bonds, hydrocarbons can be classified into three main categories: saturated, unsaturated, and aromatic hydrocarbons. Saturated hydrocarbons are the hydrocarbons consisting of carbon-to-carbon single bonds. Saturated, open-chain or acyclic hydrocarbons in which carbon atoms are linked by straight or branched chains are called alkanes. The general formula for alkanes is CnH2n plus 2. where N is equal to the number of carbon atoms present. For example, propane. Saturated hydrocarbons in which the carbon atoms join together to form a closed chain are called cycloalkanes. The general formula for cycloalkanes is CnH2n, where N is equal to the number of carbon atoms present. For example, cyclopropane. Unsaturated hydrocarbons consist of one or more carbon-to-carbon multiple bonds. That is, a double bond or a triple bond or both. Unsaturated, open chain or acyclic hydrocarbons in which carbon atoms are linked by straight or branched chains containing at least one carbon-to-carbon double bond are called alkenes. The general formula for alkenes is CnH2n, where N is equal to the number of carbon atoms present. For example, propene. Unsaturated, open chain or acyclic hydrocarbons in which carbon atoms are linked by straight or branched chains containing at least one carbon-to-carbon triple bond are called alkynes. The general formula for alkynes is CnH2n-2, where N is the number of carbon atoms. For example, propyne. Aromatic hydrocarbons are cyclic hydrocarbons with alternative double bonds in conjugation. Aromatic compounds are benzene and the compounds that resemble benzene in their chemical behavior. For example, benzene, toluene, etc. As we learnt, alkanes are the simplest form of hydrocarbons containing carbon-carbon single bonds. Its molecules consist of carbon-hydrogen bonds and carbon-carbon single bonds. Since each carbon is bonded to 4 other atoms through single covalent bonds, the compounds are called saturated compounds. They contain carbon-carbon single covalent bonds which are strong sigma bonds. Due to this, the compounds are almost chemically non-reactive at normal temperature and pressure. This is why they were earlier known as paraffin, which, in Latin, means little affinity. We have learnt that the general formula for alkanes is CnH2n+2, where N stands for the number of carbon atoms and 2n+2 stands for the number of hydrogen atoms in a molecule. The most simplest alkane is methane. It has one carbon atom connected to 4 hydrogen atoms. The next member, ethane, can be obtained by replacing one of the hydrogen atom of methane by the CH3 group. This group is methyl group, which is a type of alkyl group. Thus, ethane with molecular formula C2H6 is derived by replacing one hydrogen atom by CH3 group from the methane CH4 molecule. Similarly, an entire series can be obtained by replacing one hydrogen with the CH3 group. There is no limit to the number of carbon atoms that can be linked together. However, as the number of carbon atoms within a molecule goes on increasing, the structure becomes more and more complex. When a carbon atom is attached to hydrogen or just one other carbon atom, it is said to be primary carbon. When a carbon atom is attached to 2 other carbon atoms, it is said to be secondary carbon. When a carbon atom is attached to 3 carbon atoms, it is said to be tertiary carbon. And when all the bonds formed by a carbon atom are with 4 other carbon atoms, it is said to be neo or quaternary carbon. In a molecule, the terminal carbon of a carbon-carbon chain is always attached to 1 carbon and 3 hydrogen atoms, and hence it is called primary carbon atom. The first 3 alkanes in the series, methane, ethane and propane, only have one molecular structure. However, as the number of carbon atoms in an alkane goes on increasing, we get more than one structural arrangement for a particular molecular formula. Such compounds are called isomers. The phenomenon of exhibiting isomers is called isomerism. For example, in butane, we get 2 possible structures, one as a continuous chain and the other branched. Now, Although the chemical formula for all these structures is the same, their properties differ due to the differences in their carbon chain structure. Such compounds are called chain isomers. In pentane, we get three possible structures. 1. A continuous chain with secondary carbon atoms. Another with one tertiary carbon atom, and the third with neo or quaternary carbon atoms. Here, the structural isomers differ in the carbon chain structure and hence are called chain isomers. The table here gives the number of isomers present for a given molecular formula. Butane has 2 isomers and pentane has 3. Similarly, as the number of carbon atoms goes on increasing, the number of structural isomers goes on increasing. We come across many groups like CH3, C2H5 attached to carbon atoms. These groups are derived by removing one hydrogen